We are now discussing the rate of change, dealing with slope. We need to find out with the rate of change, is it constant or is it variable? Constant, we discussed this before, it must be the same answer over and over and over again. If it's variable, means that it will vary, our answer will vary. With that, we're going to use the equation k equals y over x. In order for us to do this with rate of change, we're actually going to see how much each number goes up or down. When we look at this first one, for example 1, for our inches, is it going up or down from 12 to 24? And we know that it is going up by a positive 12. From 24 to 48, we know that it is going up by a positive 24. From 48 to 84, it's going up by a positive 36. And 84 to 108, it is a positive 24. Remember that we're going to use our x, y, label your table, and remember we're using y over x, so I still have to see how much it's going up on our x. So from 1 to 2, it's plus 1, 2 to 4, plus 2, 4 to 7, plus 3, and 7 to 9, plus 2. We're looking for our ratio to be constant. So in order for us to see if it's constant, we're going to do the y over x. So 1 over 12, this is in simplest form. So the next one would be 2 over 24, which in simplest form would be 1 over 12. We're dividing both numerator and denominator by 2. The next one is 3 over 36. I can divide numerator and denominator by 3, and I will get 1 over 12. And last, 2 over 24, which we already did here, is 1 over 12. Is example 1 constant or variable? It would be constant because our ratio comes out to the same number, 1 over 12. All right, let's look at example 2 when we're talking about distance with miles and time speed. Again, our x and our y. We're going to see how much we jump up or down. So from 12 to 38, we are going up a positive 26. From 38 to 90, we're going up a positive 52. And then from 90 to 108, we're going up a positive 18. All right, from 1 to 3, we're going up a positive 2. 3 to 7, we're going up a positive 4. And 7 to 8, we're going up a positive 1. All right, the idea is for us to see, are we going to get a constant ratio? 2 over 26 is 1 over 13. 4 over 52 is 1 over 13. But then my last one is 1 over 18. Did I come out with the same answer or the same ratio? I did at first, but the last one, it was 1 over 18 instead of 1 over 13. So my answer is variable. Okay? I'd like you to try example 3 and 4 on your own and see how you do. We're going to go to our last component, and we want to find out with example 5. The table shows the amount of water that is leaking from a pool. Graph the data in the table and find the slope of the line and the rate of change. Okay, so our rate of change we need to decipher with our x and y. All right, how much is it going up? We know each time it's going up by 1. Okay, and we know here it's going up by 60 minus 30 is 30, 90 minus 60 is 30, 90 minus 120 is 30, and 120 minus 150 minus 120 is 30. So I know that my ratio is 30 over 1. So my rate of change is for every 30 gallons, it takes 1 second, okay, or 1 hour. All right, to empty the pool. I'm going to graph that 1 to 30, 2 to 60, 3 to 90, 4 to 120. And I can go ahead and take my straight edge and draw a line, and I know that this is a constant rate of change because it starts at 0, all right, and it's a straight line. All right, if you have any questions about rate of change, please make sure you ask, and we will go to the next video, which is interpreting unit rate as slope.